Andy, welcome. It's lovely to see you. Lovely to have you in the studio. And thank you for making the time to come in and talk to us about what you do at Hitachi Energy.
Oh, you're very welcome. Very, very happy to be here.
So before we got to the studio, I was talking to your team and they told me two very cool things about you. You do stand-up comedy and you love motorcycles. Those are very cool things.
I do. They're both very close to my heart. So first of all, a bit of stand-up comedy, entertain family and friends, and sometimes venture onto the stage. Love public speaking.
You go on the stage in front of people. Where do you do that?
Hometown, just in South London, and also in some venues around the world when I get a chance. And find that to be interesting.
Sounds so brave to me. I could never.
Some people say I never come out of that comedy routine, and I think you do need a sense of humour to be in business these days. And then motorcycles.
Right.
Big motorcycle fan. I've been for my entire life. Own a good collection of motorcycles.
Okay. Have you got a favourite?
I do have a favourite. It's my Yamaha R1, which is a racing bike, which I get to race every now and again. A bit less as I've got older, but really enjoy motorcycles, and got Ducatis and Harley Davidsons, which, if you look at the technology in motorcycles these days and the amount of advanced technology that's being used and is differentiating in the way that they win competitions, it's got a link to our industries. So we can go from the motorcycle grid to the power grid. And in fact, if you look, Ducati have been world champions in many of the formats for many, many years now. And Ducati will tell you it's not so much the engine, it's the data, simulation and the processing that they do of everything they do. So they're prepared when they get to the track. And I think there is a direct parallel from the motorcycle grid to our power grid.
Right. Power grid. You've not always worked in the power grid, so you come from oil and gas. Is that right?
I do, yeah. So I worked for 35 years in oil and gas, in software, in the oil and gas industry.
So you've always had a digital connection?
Always had a digital connection. From the very early days in the late 80s, early 90s, when we began to simulate and model oil wells and oil pipelines and compressors and things like that. And that progressed over the 30 years to be able to do those on a PC, not on a mainframe, to be able to do those live on an oil platform in the middle of nowhere in bad weather, and to eventually simulate the entire oil value chain. And that has saved us a lot of money in the oil industry, but it's also saved lives in terms of safe operation. And if you look at the number of accidents in the oil industry, they got lower and lower and lower over the decades. And that is primarily, I think, been the ability to use digital technology to predict and control systems in a direct analogy with what we need to do and are doing in the power business.
Right. So that takes me to my next question, which I want to know about your portfolio. How does what you've just told me fit into your portfolio that you manage right now?
Great question. We are enterprise software inside of the grid automation business unit in Hitachi Energy. And we've effectively got three software businesses. One is called network control, one's called asset and work management, and one is called energy portfolio management. The first one, network control, is the control of the grid operation control rooms, automation of the grid control, safety cut-offs and things like that, balancing power, moving power around. Second business is all around the people. So it's the asset and work management. So it's the data for the grid. It's what equipment is where, when was it last serviced, will it fail? Do we think it might fail? Does it need servicing now? And then the instructions to crews to go and do that servicing, or cut back that hedge, or clear that train line, and then the capture of that work when it's done. So asset and work management, exactly what it does. And then the third business is energy and portfolio management. It's the commercial side of the business. It's the trading of the energy, because not every electron is the same price depending on where it goes. So being able to model it and be able to trade it is obviously one of the most important things for our customers. And if you take those three businesses and put them together, then we're able to cover the entire value chain from plan to build to operate, maintain and trade, which is effectively the value chain of our industry.
So the three operate separately, or does one flow into the other?
Both. So they can operate separately. So some customers will just use a piece of our technology in control systems or automation, or they might just use our trading platform or carbon credit trading platforms. We believe there's significant value of putting all those things together. And our customers do need to put all those things together. And a lot of the heritage silos are being broken down. So the more you put those things together, the more silos you break down. And we're seeing it very much in the rapid advance of AI, of data processing, of data management, of analytics, that customers do want to break those silos down. They are being forced to, either by their workforce or by regulations or by the industry or by speed or business or necessity. And the ability to go from the control room to planning and back again in a very short space of time is becoming very interesting and will be an enabler from both technology and business in our industry.
So in our company, we are very technology driven all around. I think that's fair to say. We're also known for our hardware, right? We're known for switchgear. We're known for transformers. Why is software important?
It's a great question. And obviously we're a world leader in equipment such as HVDC, transformers, switchgear, etc. That equipment is becoming more and more intelligent and is expected to become even more intelligent going forward. Self-healing, self-alarming. It's no longer a piece of equipment in isolation, manually controlled. It's part of a larger network. It's part of a larger automation. One day there won't be steering wheels in cars, and one day transformers will control themselves and operate themselves and flag up conditions and potential issues that need to be fixed. So whilst we are and will maintain our number one position in equipment, that equipment is becoming more intelligent and needs to be plugged into the brain of the network. What we're doing inside of software in Hitachi Energy is creating that brain to be able to control and communicate with that equipment and get the best out of it and know when we need to maintain it, etc., or change it or improve it. So our role is very much to supplement and add value to the very successful equipment business that Hitachi Energy's got.
You mentioned this brain. Quite like that analogy. So how long has this brain been around for?
It's been 40 years or so in the making. So it started with ERP, for example, before SAP and other companies even existed for the management of utilities. Control systems have always been in place, a lot more manual than they are today. And it tended to be control rooms dotted around all over the country, which is now becoming one control room to manage the entire country. But the elements of the technology has been there for 40 odd years. Things like asset databases, SCADA real-time systems, visualization systems, trading platforms. But over the last 40 years, they've become bigger, they've become more connected, they've become more richer. And of course, the exciting advent of AI and machine learning means that we can use that 40 years of knowledge in seconds now, as opposed to days, weeks, months, and years. So very, very strong legacy over the last 40 years, but the rapid rise in the value of that data we're seeing now, probably orders of magnitude faster than it was 40 years ago.
So what triggers this evolution?
Customers, number one. The utilities need to do more. Our industry is under a lot of pressure. We know a lot of the numbers around the amount of power that data centers need and the increase in power for that, the increase generally in power required in the system, the decarbonization of systems worldwide. Our industry has to move faster than it's ever moved before. It can take years today to plan to put a battery storage system into a grid network. We don't have that luxury of waiting for years in the future. It's going to have to be months as opposed to years. And to do that, we need to be able to do what I said earlier, which is plan it, build it, operate it, maintain it, trade it in a cycle that doesn't take 7 years anymore, takes months to a year. And the only way to do that is to break down the walls between silos, bring groups together, share the data, and run the contingency analysis is much, much faster. So it is a natural evolution of the power requirements and the pressure that our industry is under.
So you listen to customer needs, and then do you partner with software expert companies specifically?
We do. I'm a firm believer that we cannot do it all ourselves, and we shouldn't do it all ourselves, particularly if somebody does something in an evergreen way that is much more sophisticated than we would ever do it. I think one of the mistakes sometimes industrial companies make is trying to write their own platforms for everything when the Microsofts and Google and Amazons and Nvidias have already done it. And we should also learn from what other industries are doing. We referenced oil and gas, for example, a moment ago. So our strategy is very much around ensuring that our content, our 40 years worth of investment in our industry specifics is protected and it's grown and it's improved, and then use industry technology and partner with people like Microsoft, like Amazon, to take fabric or AI or clever mathematics or analytics that are used in other industries and supplement them on top with our knowledge. And that is a big pillar of our strategy. And we've had many announcements recently of partnerships, with more to come, with the hyperscalers and with other companies that will drive that technology and that innovation. And what we find is that is a much faster way to market and a much more reliable way to market for our technology and our content, working with third parties such as Microsoft.
So, and with such a broad portfolio, I'm sure you've got many success stories. Could you share one or two with our audience?
Yeah, we have many success stories with partners, and some of those partners are customers. And we like to collaborate and cooperate with customers. And we believe when you're at the edge of innovation, that is the best way to test it, the best way to use it, and make sure that the value is achieved, because that's what we're all here for ultimately. And we all know that a lot of technology doesn't end up becoming anything. So prioritizing and testing and ensuring that there is a good use case, I think, can only really be done with customers. So I can talk about a few examples.
Yes, please.
There's a very large one in our mothership's home country, Japan. TDIOS is the transmission and distribution operator for the whole of Japan. There are 10 TSOs, 10 transmission companies, and they are on a journey to unify the network digitally, the power network digitally, the grid in Japan, and be able to do load balancing, be able to do load frequency control across the whole of Japan, from generation to consumption. We won that project a few years ago. It's in delivery now. It'll be commissioned and delivered in around about 2031. So a very large project, many hundreds of millions of dollars. And that is a partnership between the Japanese operation system, TDIOS, Hitachi, and Hitachi Energy. And for that, we are developing new systems for energy management, new systems for market applications and trading, and world-class new optimization for load frequency control. Japan has got 2 different frequencies, a number of large tie lines, and 10 system operators. And we'll be delivering the largest EMS system in the world that will control all of that from one place. And that is really exciting. That's going to be a world first. We then have a number of other projects that are quite interesting, completely different realm, completely different perspective. We've commissioned our first ever SCADA real-time control system for a US operator in Amazon Web Services. So there is no local infrastructure. There is no control room. It's for Conduit Power, which is an independent power producer in the US. They're a renewable producer, and they didn't want the expense and time taken to build a control room and all the infrastructure. And they are our first customer that's put the SCADA system directly into the cloud. They can operate it from their offices. They can operate it from home. There was a situation in the US recently in Texas where there was a big storm, big hurricane, and they were able to operate their grid, their renewable system from home and maintain power all the way through. I made a statement a few years ago that I didn't think in my lifetime I would see a SCADA control system in the cloud. And I was wrong again. It does exist on a small scale, but that is just how many things start. So that was a very interesting project to go directly to put a SCADA system in the cloud, operating a renewable energy system.
How long for it to become mainstream, do you think?
I think it's got a few years yet.
Okay.
It will probably grow inside the renewables business, where there is more opportunity, that things are more remote, they are more distant. Sometimes that there isn't any logical area you can put a control system or a control room. I think it's got direct application in the renewables industry. Of course, many customers in many countries have to treat control rooms for the power grid as a key asset and would not put that in the cloud at any time soon. But we are seeing even those customers under highly regulated operation still want to use cloud-based technology to interact with the control rooms. So one of the things that we are seeing is a direction that a lot of customers are taking is we want to put more applications in the control room, and we want more data available outside of the control room. So it used to be air-gapped, and it used to be cut off, and it used to be its own thing. That, unfortunately, leads to a lot of silo behavior because you can't communicate or use the data. And what we are seeing now is that, particularly in transmission system design, is we want to get more stuff in the control room, operating and optimizing the network automatically. But at the same time, get that data out to other groups, planning, scheduling, etc., management in the operator. And to do that, we can use cloud technology connected to the control room. Of course, cybersecurity is a very big deal and a very important thing in that environment. And Hitachi Energy is very strong in the cybersecurity area. One of the world leaders, from our mothership technology to Hitachi Energy, we are certified, approved, and a lot of awards won in the cyber area, which is interesting. A project that I'm really interested in is something called SPP, Southwest Power Pool. And it's the first time we've used large-scale AI to do analytics around the grid. So Southwest Power Pool is a conglomeration of 14 states in the US, 14 transmission system operators in the states. And they have to plan together to put things into the system, either batteries or renewable wind farms or solar farms, etc. And as I mentioned earlier, in a lot of places, that can take years and years and years, because particularly here, there's 14 states that are interconnected. It's a very complicated project to do the simulation, to do the contingency modeling, to pass the regulations for being able to build it, and then to actually build it and put it into play. And what we find early on in the plan phase is we're running hundreds and hundreds of thousands of scenarios of where to put that generator or where to put that battery storage, because there are so many permutations of where you can put it. And if we can shorten the front end by 1, 2, 3 years using whatever technology is available, that will add a lot of value and will give a lot of flexibility to those states in particular and to operations. And we've got very sophisticated simulation digital twin technology. It just takes a very long time to run. And what we found is we can train that technology using machine learning and AI, and we can get the AI to run it in substantially quicker time. Think minutes as opposed to months to run all these scenarios, and then rerun the scenarios, and then calibrate it against the real world simulations. And using AI to speed things up looks very, very promising. We've already announced the project, and we will be announcing some of the results soon. And what we will be able to do, we think, is reduce 5, 6, 7 years to 1 to 2. So probably a third of the time to bring generation on board, bring battery storage on board. So look out for those announcements. Southwest Power Pool, SPP, lots of stuff coming up soon. But that's very exciting. Taking traditional digital twin technology, coupling it with AI and ML to speed things up, make them faster, spot problems earlier, all within a customer called SPP that's watching and helping us and adopting it. And the great news we heard recently is that they've already begun, the customer's begun to use that data in this year's planning cycle well ahead of time, and that's brilliant.
That is very exciting. Very, very exciting indeed. You've just touched upon it, but as we enter the next era of electrification, what steps do you think are needed to make legacy systems more visible and connected?
That's a great question. A lot of these legacy systems obviously contain a lot of data. A lot of our history and our knowledge is locked up in these legacy systems. It's really about getting that into the brain, allowing the brain to be able to see that history, be trained, use AI, as we've just said a few moments ago. And I think it's a number of elements that will play. First of all, if we go back to Hitachi Energy strength around the machines, around the kit, these grids are some of the largest machines in the world. They need to be automated. And to automate them, they need to be intelligent. And to be intelligent, you need sensors. So a lot of big projects on putting sensors into our transformers, into our switchgear, and having those sensors being able to do a number of the processes at the edge, not wait for a control room thousands of miles away, but be able to be automated at the edge. So number one is the instrumentation and automation at the edge of our equipment, and great to see Hitachi Energy strengths in that area. Secondly is to be able to gather all of that data, which is orders of magnitude more data than we've ever processed before, and bring that in and be able to process it quickly. And that is where AI and ML plays a large role going forward. And then being able to compare that to historical data in the legacy systems and make that data available. And we're finding that for the likes of Microsoft Fabric or Google GCP or AWS, we've got access to multiple legacy systems and being able to search them very, very quickly. Some of the partnerships that we have are with smaller companies, startups. We've got very sophisticated semantic search technology that can, embedded inside of our legacy systems, can search for things and bring it through Microsoft Fabric very quickly to an operator or to a worker in the field. And so the ability for us to search the legacy systems, compare it to the massive volume of data that's coming in from the field, and come up with that 1 or 2 or 3 priority work orders for a crew is vitally important. And then that gets into visualization, getting it into the hands of the operator or the crew very, very quickly. So for me, it's automation at the edge. It's using AI and ML to semantic search all the legacy technology, underpinning it with Fabric from the likes of Microsoft or Google, and then presenting that in a very simple way, in a simple interface for an operator or a crew member so they can take action immediately and shorten all those cycles from days, weeks, months, years to minutes. It is where this is going. So it's matching legacy with data and automation, putting it in a brain and then presenting it to a user as fast and as furious as we possibly can.
And if we go from legacy to future, do you think there's room for autonomous control rooms, for example?
I think there is. There certainly is. Again, as we said with the conduit power example, in smaller renewable offshore wind farms, they'll probably be the first place it happens. 30 years ago, I was working on offshore oil platforms. And over those 30 years, most of those platforms have been demanned, and most of them are autonomous now. There was a joke in the oil industry, back to my stand-up routines, there was a joke in the oil industry that most oil platforms would be one man and his dog. The man's there to feed the dog, and the dog's there to keep the man away from the controls. And that's very much where we'll go, I think, in offshore renewables and remotely controlled solar farms and things like that, and battery systems. But we will begin to see a lot more automation in our bigger control rooms. And I think it will start with enabling people to do more so that the crews and the operations teams that work in those control rooms, give them more tools that they can take GIS mapping and map it against alarms and alerts that are in the system and make those alarms smart. So quite often in the control room, you spend hours and hours looking through alarms, trying to work out where the root cause is. Well, why can't we present that root cause immediately from smart alarming on a GIS map and show where the latest crew is?
Gas insulated switchgear? You're talking about substations?
In your world, that's gas insulated switchgear. In our world, that's geostationary mapping systems.
Geostation. There we go.
So
glad I asked.
Geographical information. Yeah. So the ability for us to present that information to an operator and save the operator hours and hours of trying to search out where this root cause problem is. Because, in the grid, you'll get a trip and it might trip in 9 or 10 places, but most of them are a follow-on from one specific place. If our systems can identify where that trip root cause is and present it on a map and show where the nearest crew is that are trained and have the expertise to fix that particular problem, or your switchgear or our switchgear, then that's going to really begin to reduce the time and cost of maintaining and operating the grids. So for me, before we get to fully automated and demanned and dehumaned control rooms, which are a long way off in our core business, I think it's more about empowering the operations teams that are in there so they can do more, do it quicker with the limited resources that they have. And as we know, our industry is struggling with resources, don't have enough people working in the industry. So we have to empower the ones that are there.
Mm-hmm. If we stay forward looking, and as my last question, I'll ask you, what have you got your eye on? What do you think is the next big thing?
I think the next big thing is optimization. It's taking a lot of the mathematics that we've developed in an offline scenario. So I talked about Southwest Power Pool being able to run huge volumes of contingency analysis, but it takes years to do that.
Right.
And then bring that into an operating scenario. And I think the combination of the improvement in mathematics, the ability to put that into large clusters like NVIDIA clusters and solve optimization problems that might take us weeks, months, and years in seconds is where the next big change is going to be. Our customers are trying to do that. We talked about Japan doing load frequency control across the whole of Japan. We need to do that in microseconds, or certainly seconds, as opposed to minutes, days, weeks, and years. And using NVIDIA clusters, we partner with NVIDIA, for example, using NVIDIA clusters and their QDIS mathematics solvers with our digital twins, we have been able to prove in the Japan project in particular that we can do a load frequency control and optimize generation to distribution in the entire country of Japan in under a second. And that is, I think, where the immediate future is. And then, of course, the knock-on use of AI around that to be able to look into the insights of all that information and that optimization that we're doing. So the next big thing coming is automated optimization in control rooms and bringing planning and operations much closer together.
Oh, thank you so much, Andy. It's been wonderful chatting with you this morning. And next time you do stand up, please do let me know where it's going to be. I'll be there.
Right.
I want to see
I'll
this.
throw in a few electricity jokes.
Deal. Thank you so much.